Section 11.1, Systems of Linear Equations, Substitution and Elimination. This problem says solve the system of equations. If the system has no solution, say it is inconsistent. Graph the lines of the system. So we're going to solve this system of equations first, and we're going to use the substitution method first. So what that means is I'm going to substitute somewhere throughout this process. So what I'm going to do is I'm going to pick either the first or second equation, and I'm going to solve it for either x or y. And I notice in the first one, if I solve for this x here, all I would have to do would be subtract 3y from both sides. And that's actually the easiest thing to do for all of these. So I'm going to pick that one and that first equation and solve it for x. So this is what it's going to give me. So now I got two different ways I can choose to do this problem, either substitution or elimination. I'm going to pick the substitution for this one, just because I wanted us to try both methods. So substitution method. And I'm just going to write that here for your sake. So now the substitution simply means I'm going to solve for one of the two equations for either x or y, and then I'm going to plug that into the other one. So where I see x in the second equation, I'm going to plug in x for it. So I'll show you what that means. Okay, so if I have a 2 here, that's that 2. Okay, and then I ran into an x. So instead of the x, I'm going to put negative 3y plus 5. And then I have a minus, then I have a 3y, and then I have equals negative 8. So essentially, I just wrote the second equation down with just, instead of x there, I put negative 3y plus 5. Okay, so now I'm just going to simplify this and solve it for y. So then I'm going to get negative 6y plus 10 minus 3y equals negative 8. So that's going to be negative 9y plus 10 equals negative 8. And then I subtract 10 from both sides. So negative 9y equals negative 18. So then I'm going to divide by 9. So y equals 2. Now keep in mind what we're doing here. We have two lines that we're dealing with here. This is one line, that's another line. And we're trying to find the solution for these two lines. So we're trying to find where these two lines intersect. So if you think of two lines intersecting, they intersect at a point. That point has an x value and a y value. So we actually only found the y value of that point. So now we have to plug that in and find the x value. So I'm just going to plug it into the one I have up top here. So this is going to be x equals negative 3. And then my y is 2 plus 5. And I'm going to get x equals negative 1 when I do the math there. So my ordered pair for this is going to be negative 1, 2. So there's our answer for this system of equations. Now it tells us to graph this. So now what we're going to do is we're going to graph this. So we have these two lines up here, and most of you probably forgotten how to graph already. So let's talk about this here. So if I try to solve this for y in slope-intercept form, I would actually get a very ugly answer, I think. I mean, I could deal with it, but I think there's nicer ways to look at this. Essentially, the way I would do it is I would just try to find 2 points for each of these. I wouldn't want to do y equals 1/3 x, and it'd be a negative, plus 5/3 as my equation in slope-intercept form. That would be terrible to look at and go through points to try to find nice points. And what I mean by nice points are where my x and y are integers. So I'm just going to go through finding points for these. So the way I would do it is when I see this x plus 3y equals 5, which is my first equation, I'm going to call that 1, and I'll call this 2. Okay, what I'm going to do is I'm just trying to find easy numbers I can plug in. So I see if I plug in 0 for y, that I see that that's going to give me x equals 5, and that's nice. 0, 5 is a nice answer, but it wouldn't be 0, 5, it would be 5, 0. So be careful, because my x is 5 and my y is 0. Okay, now I see that I can pick another, nice value for y that would make it easy too. So then another value I could pick for y would be 1, right? So that would be x plus 3 times 1 equals 5. And then that would be 3 there, and when I subtract 3 over there, x would be 2. So 2, 1 would be a good number too, a good ordered pair. Okay, now I'm going to do the same thing for the second equation. And honestly, I'm just looking for the easiest way to do this instead of trying to find numbers that work. Just plugging stuff in randomly gets a little bit more difficult. So that's the way I'm going to handle this. So now I can do the same thing for 2. So I have 2x minus 3y equals negative 8. And one thing I noticed right away is that this is an even number. And this is going to be an even number. So if I can get rid of this, that's odd, or it could be odd, could be even too, then that would make my life easier. So I'm just going to plug in 0 for y. So that's going to be 2x minus 3 times 0 equals negative 8. So then 2x equals negative 8, which means when I divide by 2, x equals negative 4. So I get the ordered pair negative 4, 0. And then I need one more point here. So now I'm going to find another point. Need one more. And one way I can think of this is, notice, I already thought about this here being even and that being even. So if I could make that even, then I'll probably have a good chance that it'll divide. So what I'm going to pick is 2, because 2 times negative 3 gives me negative 6, which is even. So I'm going to do 2x minus 3, and I'm going to plug in a 2 there, negative 8. And then I'm going to get 2x minus 6 equals negative 8. And then I'm going to add 6. So then 2x equals negative 2. So x equals negative 1. So I get the ordered pair negative 1, 2. So there's my 2 sets of ordered pairs. And again, once I have those, now I can actually graph the equation, because all I need is 2 points to graph a line. So I'm just going to do that now. And again, I could do slope-intercept form, but it's going to be a lot more difficult to find those nice numbers, integer numbers for my x and my y. So anyways, 5, 0 is our first point. So 1, 2, 3, 4, 5. So I put it here. Okay, there's our 5, 0. And then our 2, 1. So to the right 2, up 1. So that's going to be there. Okay, so there's our first line that we can draw now. All right, so there goes my first line. So now I'm going to do that with the second line. So I'm going to call this 1, 2, so we don't lose track of which line was which. Now I'm going to do the other line. So I'm going to do negative 4, 0. So 1, 2, 3, 4. So that's here. And then my other point is going to be negative 1, 2. So that's here. And I'm going to graph that line. There's my line, and there's my second line there. And notice where they intersect at. That's here. That would be this point right here. And that point is negative 1, 2. So they want us to graph it so we can get a nice visual of what our solution tells us. And then if you look at what we got previously, by doing the substitution method, we realized it was negative 1, 2, which should have given us the same answer. So there we go.